It is my pleasure to introduce to you someone who is very well known here inside of Microsoft and hopefully outside of Microsoft. In fact, he's a man who is so well known, he didn't have to submit an abstract or a biography to get accepted to BlueHat. So with that, please let me introduce to you, Elia Florio.
Thank you. Hello. Let's see if it works. Oops. Does it work? Yep. Hello, everybody. So apologize for the TBA. Actually, I got tons of requests. So like, what was this mysterious talk with TBA? And I was having two choices. Either trying to come up with an acronym that TBA was some fancy new type of threats, and I wasn't cool enough to do it. But the other acronym was, oh, my talk is redacted because somebody, was asking to pull the talk out for some legal reason. They were like my two kind of, backup plan. But yeah, that's actually my talk. It's about supply chain, and I decided to take a look back. I presented actually about supply chain at RSA this year in April, and it was a little bit of a review of the last decade of software supply chain attacks. And by the end of the year, there was a lot of talking about this kind of new emerging, kind of old or new threat. And I decided to say, okay, let's see how the prediction, how 2017, all the companies, everybody was talking about supply chain and what's happening in the first half of 2018 and where are all these attacks going. So the talk is going to be 30-minute talk. Hopefully it's easy enough. It's after lunch. You guys are probably relaxed, having some coffee. But we'll try to take a look to this new type of threat that it's kind of becoming a hot topic in security world. So supply chain, this is becoming the next buzzword. Every conference I'm being, or every security partners or researcher I'm talking about, they're talking about supply chain, and it's becoming almost the replacement for zero-day, where basically you don't see now attackers coming on with zero-day vulnerabilities, but more with supply chain attacks, where basically they try to compromise some company or a partner to breach into somebody else. I didn't think it was a buzzword, but by the end of the year at RSA timeframe, I think, oh yeah, this thing is spreading around. It's very viral. RSA, I think I was probably one of the, I'm going to only one talk about supply chain. They have gazillions of supply chain attacks talk. And then after that, it started to move into the news sphere, and also you see appearing articles, dark reading. It went to Wired and also Forbes. So it's pretty much almost everywhere. It's becoming the next buzzword. I'm still waiting for somebody to come up with a good acronym. I saw some researchers calling about SSC, like software supply chain compromise, something like a new. But that's basically the new type of attack vector that a lot of security companies are seeing on the radar, and they are trying to understand and emphasize basically companies that need to be aware of this new threat vector and try to do something. So in this talk, basically what we do, we'll try to recap from my previous research that I published at RSA, so looking at what was the trend that we left in 2017. We have two new examples of supply chain attack. There were two incidents that the Windows Defender ITP team detected, so we can look in details some of the one that we just found with our own eyes, and we just look at directly. And then the last part was about, okay, where the attackers are going, and basically what is supply chain? Is really such a big threat? Are we really seeing the hype that everybody predicts? Or it's just like a big container or a buzzword where a lot of people are classifying supply chain, but in reality, this is not the case. From RSA, this is numbers that I pulled up after looking at almost a decade of supply chain attacks. We are talking about incidents here, so it's not about victims, it's not about how many machines were affected, but just individual instances of supply chain incidents. So we left 2017 where basically we had at least 7 unique incidents affecting thousands of enterprise and companies around the world. You may remember probably the last 4 years, basically. If you guys don't recall, but MEDOC probably was the most famous one. Nobody probably knew MEDOC company until Petya came out. It was a very obscure tax company in Ukraine. And when Petya came out, it was discovered that the entry vector mechanism to distribute Petya ransomware across Ukraine, it was this company, which is a very large user base only Ukraine, but not around the world. Still, this thing was enough to make a lot of damage. And then all the other attacks were in the news. Probably you heard about CCleaner, and there are a bunch of very interesting presentations from Cisco Talos about that, where they did a lot of forensic on the supply chain. There was also ShadowPad that was affecting, basically was affecting some Chinese company making a remote administration tool. So that were basically 2017 was becoming a year where this trend started to become much more worrisome for companies. We saw the prediction 2017. I'm putting here the one that were basically all around. So we got all the names: Kaspersky, CrowdStrike, Microsoft, Palo Alto. So I mean, just pick up the most. But everybody at the end of the year, if you pick up this report, they were predicting, oh, we're going to have an explosion, or we're going to have a lot of more supply chain attack in 2018. So was this prediction true? How are the numbers looking at Alpha 2018? That's what we are trying to look today. And from our side, we saw the first two attacks with direct telemetry. So these are two supply chain attacks we discovered. We're going to deep dive into these attacks in a second. And the last one was reported recently by Trend Micro. But so far, yes, 2018, first half, we had 3 instances of supply chain software attack where some form of binary was compromised at the source and then distributed across users or enterprise that they don't know about it. Let's go to look quickly at the first one. It's a software called MEDIAGET, and it's not very popular in enterprise, but you may have users that for poor hygiene or for, you know, they're free to install software, they may download this client. It's pretty much a peer-to-peer sharing application. It's based on top of a torrent. So what's happening is that one day, one of our system, you know, we have this magic room where all the telemetry came out, and one of the charts was showing some situation like this. We have almost 400K new infection of a special strain of a malware that we call Dofoil, that basically they were showing up all around the world in just a few hours. This is, you know, and this thing was also, by the time, probably Jessica remember because she was here, like, well, by the time right after all the ransomware epidemic, so we were panicking, oh yeah, there could be something big growing, and Russia was really like targeted, I mean, all the Eastern Europe was really targeted heavily. So, you know, we have few hours, 400,000 machines showing the same type of file or malware getting installed and dropping other components. That was kind of a little bit of a worrisome situation. So we spin off our research team and we started to look at how this thing was happening. You know, was another Eternal Blue, was some other exploit that we don't know. The interesting situation was that we ended up looking at the infection chain through the telemetry, and we were seeing that all the machine infected, they were showing this MEDIAGET.exe doing strange stuff. After, you know, a bunch of hours of research, and we were a little bit confused at the beginning because we were seeing MEDIAGET being signed, and then another unsigned MEDIAGET doing other strange stuff, and we don't know which one is the good one and which one is the bad one. So the situation was that we were having multiple MEDIAGET processes running. One process was actually downloading our components, then dropping something else and running it. Now, the most interesting piece of this attack is that some of the MEDIAGET components were signed by the legitimate software producer. So the company which makes MEDIAGET was really like distributing software. But then during the chain, there was another software component that was signed with a certificate from a Mexican developer, from like, you know, it's a Mexican software developer company. I think it's the third row in this table, which was kind of, oh, this doesn't make sense. Why a software developer in, you know, should drop another component, sign it with the different certificates, and then this component was doing other weird stuff, right? So pretty much at the end of our analysis, we realized that there was a supply chain attack where we are pretty confident that basically, yeah, there was something going on the build and distribution server of this software, because the MEDIAGET was downloading an update, and then after the update was installed, they were downloading additional components like this my.dat file that will become now this Dofoil campaign, installing a coin miner at the end. So the entire cycle took probably a couple of months. We think that probably the breach happened very early. We are not sure even like if somehow there was somebody involved from the company inside basically the MEDIAGET distribution where basically some developer was compromised or they lost the credential. The thing that was interesting, and that's why we are towards saying, oh, even if this software, you know, it's an unwanted software. You don't want to have a torrent application on your network, right? And some antivirus that detect this as a potential unwanted application. But we were going like through two major plans. Like either the company is going completely rogue, where basically still a supply chain, where basically the company decided to actually do bad stuff, or they are victim of somebody attacking them. We think it's more the second scenario, even if we don't have the 100% confirmation, because of a couple of things. So first of all, the certificate was a bypass that they need to use because the updater was trying to run anything that is signed with the certificate. So this means that basically, if the attacker was not able to re-sign the malicious packages, they won't be able eventually to run anything else. So that was something that our researcher looked at inside the code and justified the fact that they have to obtain another certificate, from a random company in Mexico. And then the second part is that from a bit-to-bit comparison of the MEDIAGET client, we saw that basically the build was pretty much the same. Everything in the PDB and the bug information was was matching with the legitimate build, but they actually added a run command to the update protocol, where basically now a remote attacker was able to trigger a remote execution with an update and basically run arbitrary code. Yeah, that's pretty much how the chain will look in the Windows Defender ATP, and you see all the different components. And there was one of the supply chain that started in March, and we were able to detect. And again, we detected this stuff a little bit in the middle of the kill chain because we weren't sure at the beginning, like, oh, is MEDIAGET legitimately downloading and updating itself, or this is an attack? The next one we want to talk about is something that's another supply chain. It's a little bit more interesting, and this one we really don't have doubt that there was an attacker going after a plan and tried to compromise this company. So yeah, that's GeoSecurity actually took some of our samples and tested it, and they were able to just demonstrate how, we have a font package that is installing and downloading a coin miner malware. So this attack also started looking at telemetry of different machines. So the way how we detected this supply chain incident during April was a series of machines with absolutely no relation between them, even like showing in different organization or industry. They were basically being compromised and showing a similar piece of malware, which ended up being a coin miner. And then all these machines, they were just chiming to the same process. And we were not able to figure out, okay, why MSI exec at some moment is start to execute malicious code and install this package that it's basically something bad that we don't want. It took, again, a little bit of investigation. Usually, supply chain are very hard to detect because they are coming from a trust relationship. So basically, the victim has some kind of trustworthy relationship with the software or the supplier. And so it's very hard to see if the entry point is maybe software which has been affected, or an updater, like in this case, or eventually it could be like, some other entry vector. So in this case, after a bunch of investigation on the box and forensic, we figured out that there was a MSI package that was downloaded and launched by a legitimate updater. So there was a software installed on the box. This software was, a popular PDF editor application, something that it's, it's not popular as Adobe, but it's a very small, minor, this alternative PDF editing app. And this application, during the installation update chain, at some moment, it started to download an MSI package, which was really a replica of the original installer, from another server that I think it was located in Ukraine. And this was something like inexplicable, like why this legitimate updater should now download a package unsigned from Ukraine. And then in the end, what's happening is that this thing was installed in the coin miner. We contacted the software company, and we had back and forward with them. Usually, every time we contact a supply chain, during a supply chain incident, if you contact a company, usually the first reaction, no, this is impossible. You guys are telling something which is not real. And then after a couple of emails and showing the telemetry, things get a little bit better. So they were very helpful. But still, after a week of conversation, we still not be able to understand, okay, what's happening? Why this company is distributing this? Even the company itself, they didn't know. They checked all the infrastructure. So what's happening is that after digging more and more, we figured out that this was what we call the supply chain of a supply chain attack. This company relies on a third-party company, which actually makes font. So this company makes font packages. And they have a partner relationship. They sell the font package with some license agreement to this software, PDF software maker, and then the PDF maker gets installed by other companies. So what happened is a very complicated case that after a back and forward, the font making company, which was a separate entities, they had one of their server compromised. So we think that the attacker was able to study the distribution process where the PDF software at some moment is able to go and reach out the third-party company and get the most updated font package. And then they were able to create a replica server that was exactly looking like the real update server of the font company. And they were putting all these font packages, except for one package that will eventually contain the malware and distribute it. So PDF company, completely uncompromised. They were fine. They didn't have any problem, no breach, no attacker on their network. But because they just downloaded and rely on another third party, and they were installing malware on other users. So that's kind of the complexity that we kind of foresee with supply chain attack, and gets actually a little bit more amplified by the fact that on the cloud, all this interconnection and complexity, they get a little bit more complicated. The attacker in this case, they were also smart enough because they realized that this font-making company was also somehow licensing or selling their font packages to other PDF applications, still minor, little alternative PDF. And basically, they were trying to also prevent updates. After installation of the malware, they were trying to prevent updates from the legitimate company in order to don't remove the malware. And again, if you can go on VirusTotal, you can even see like how this MSI package was downloaded. The main problem that also, beside the lesson of supply chain, which is the linkage complexity, we learned also that most of the developers, they still think about signing and code signing, still about, oh, this is something only for binaries, for executables like DLL, XC. But in a modern world, and we'll see a little bit later, code signing and trust is something you have to build across everything that you run. So running code, remote code execution is not something that can happen with the XC or DLL. These days, we have things like MSI packages. We have cab file. We have PowerShell, JavaScript. Tons of different objects that, for the reason or another one, they ended up in our system running code. And not all of them, they have like a level of trust like actually we have with the legitimate. So in this case, in the legitimate binary, MSI was not signed. And so if the company, for example, the PDF company wanted to prevent these things, they will have just to check if the MSI package is signed with the legitimate certificate. At the end of the story, there was one of our colleagues in Israel. He tried to estimate how much the attacker made. Making actually $60,000, pretty much more or less, in a couple of months for an attacker is kind of it's a good opportunity. So that was the estimate we made from the CoinMiner account that was associated. And the final case here is from Trend Micro. It was very recent. I don't have much more details. I'm just putting here for reference. This one, it's also very ambiguous because it's a remote access tool, which is basically, it's either an attacker going after another attacker. I will not say it's really a supply chain, but it puts you this warning here. We're basically remote access tool. This tool that give you access to your box from anywhere in the world, they can be compromised. And actually, these are actually the most appealing companies where some attacker, if you compromise a company that can give you remote access, this basically will cause a lot of problems because, even if you don't install the software, just the access itself is a very valuable commodity in the attacker world. So watch out also for remote access tool because that could be the next big prediction happening. So where we're going with this is that in 2018, if we count only the software binaries incident, we are just having the tip of the iceberg. Yeah, we got 3 interesting cases. There are more supply chain happening, but what's actually more worrisome is that if you start now looking around and what people are classifying as a supply chain, there is this bottom part of the iceberg where now we have all these objects in the cloud that they somehow run code. And they can run code even without the human intervention. We have Docker containers, Node.js, other NPM modules run arbitrary. So what's happening is basically now an enterprise org nowadays is all this trust relationship with all these suppliers. We have hardware suppliers, software suppliers, we have open source suppliers, also we have vendors, partners, acquisition, the remote access, and also, we have this link relationship built across all the chain. When you put the cloud, what's happening is that now all this relationship gets extremely much more risky, and they need to be actually vetted. Before, a lot of this stuff, if you're having a vendor in your company, then you can somehow trust the physical access, you can give them badge, you can somehow enforce some security. But now if your vendor is in another country and connected to you to the cloud, how will you ensure that the same security apply to them? Same story for the software company, the hardware company. You're getting all this supplier and you don't know. So this means that now all of this suppliers, they become potentially a very, very valuable entry vector for attackers and a big risk for companies. I try to look around, looking for things like Chrome extension updaters compromise. This is from Iceberg, and they found out a lot of this extension on the official Chrome store. They worked with the Chrome team to remove all of them one by one, and they were compromised, and they were basically downloading a new Chrome extension. And Chrome extension, they run code. Yeah, they run code inside Chrome, but they can execute JavaScript. Another Chrome extension that was also compromised, Mega, is the popular distribution like sharing website. They have an extension on the Chrome Web Store. The developer of this extension lost the credentials. Somebody logged in, replaced the extension, and everybody downloading it was installing another malware, which is an extension. It's not binary, but still, this thing executes code. Looking like these are other two incidents on the Linux open source community. Luckily, none of these ended up in a bad story, but when you read that either the GENTOO distribution credential were compromised or the other distribution Arch, then these are like worrisome trend, because you see now people going after Linux open source repository and try eventually to compromise them. Actually, the second case is still not know if it was like somebody tried to warn them, because if you read the story, like they just left a malicious script that was just writing a file, compromised txt on the main partition. Moving forward, yeah, WordPress has been in the history for a while. WordPress is a good company that track all of them, but these are all examples of objects in the supply chain world, which are in the cloud, which actually are big risk now in modern days. So I think like moving supply chain from just the binary to other objects like this makes sense, and that's why a lot of companies are predicting this expansion of supply chain problems. Finally, yeah, we have also npm packages. This is also again modules that run with JavaScript, and the most interesting is this one. Yeah, this is a Docker image. Docker image uploaded on Docker Hub. It took 1 year to remove the image, and it was pulled out 5 million times. It's an entire operating system. It's not anymore a file. It's not anymore a library or a module. It's just an entire Docker image, where actually the attacker uploaded 14 different of this image, and people were downloading it and using it until they were just noting, hey, I have this bash script that now reach out and run something. Yeah, I know Linux has also a good verification for binaries, but then how do you defend against somebody modifying a cron script or some bash shell inside the Docker image? So this basically goes back to the principle of trust. So in this kind of world where basically, the cloud is opening a little bit more of this trust relationship, and basically we are trusting more suppliers. Now the problem is that things like, digital signature and authenticode, how do we move this type of trust to these objects? And we are able eventually to kind of guarantee that basically every code, every package, every library, every Docker or container image we run has the same degree of trust that we normally have, for example, for like Microsoft binaries. So that's, I think, where the major problem is kind of coming from, and why the supply chain should be actually looked not just as a software binaries problem related only to Windows World, or eventually to software bundle, but in general as anything that is a supplier, any company supplies something, then it could become a target, and we should took this thing a little bit more as a holistic problem. These are a little bit of the conclusion and takeaways. It's a short session. It's more about trying to kind of raise these type of problems and open the eyes. But in general, software supply chain, we are seeing some binaries form, but basically it's not just happening at binaries level. The new variation we are seeing is that anything that is a supplier, either it's a remote access or it's a container or it's something that our company runs, that basically could become an issue. Also, we are seeing this thing moving from national state attacker to more kind of lower level criminals or more kind of coin miner. This is also worrisome because this means that these people find this thing attractive. So either because exploits are getting much more harder to be found and exploited. So these are actually like much more cheaper revenue. Of course, DevOps or whoever is maintaining a distribution, a repository, or a package are the weakest link of the chain. So we should invest a lot in protecting this practice, with the two-factor authentication. We harden the workstation. Here in Microsoft, for example, we have a special workstation that we use eventually only for certain type of activities. And this concept of having admin only with the very special lockdown workstation, it's actually something that every company that is aware of this attack started to put in place for security. Also, the concept of remote code execution or code execution, as we know on client application, I'm very familiar with when Office eventually tried to run a macro, try to have an exploit that can run something remotely. But now, if I have like a library, or imagine I have a container which install a library which install another component in the cloud, this concept gets very, very broader, and there are so many implications in that we should think about code execution in the cloud a little bit broader and try to come up with eventually more mitigation ideas in this space. I saw also, there are new emerging models. For example, there are companies that certify, guarantee, and test NPM packages. So, for example, if you want to trust something, this company, you have to pay, you have to subscribe their model, but actually they're creating this business because actually companies are trying to rely and use, certified NPM modules. So this is also opening opportunities for new, say, company can actually make some trustworthiness and actually can confirm that some of these packages are original and clean. And yeah, finally, detection is still hard because all of this point we don't have visibility, and we have good visibility eventually on the endpoints when these things arrive on the workstation, but yet on the server it's still a little bit of a problem. I think with this one, it's pretty much all I was have to say on this one. And if there are questions, I think there are 4 or 5 minutes left. Thank you.
Hi. There is any roadmap for ATP to have a feature like either a block or uninstall the application itself, which is a victim of supply chain attack, or having a network access control in place which says end user cannot connect to the corporate network till the time entire compliances are not met. Okay.
Yeah, we are working on supply chain guard. No, this is a joke. Don't quote it. No. Yeah, actually, the problem is a little bit serious because detection it's hard. So things that we are putting together into the ATP kind of ecosystem and into the P package, if you think about all our Windows Defender application control and all the coding integrity enforcement that you can apply, it's still a little bit trickier to use. We hope that we can get a better customer experience. But for example, you can enforce on a Windows platform a lot of the code integrity you want and what you want to trust and what you don't want to trust with the application guard, Windows Defender application control, sorry. And this is part of ATP. Now, ATP itself, it can raise some of these attacks sometimes when we observe anomalous certificate or pattern like that. But I think, yeah, we still have to kind of work to get a much more holistic supply chain protection.
Yep. Do you think that the App Store distribution model helps or worsens this supply chain problem, like the Windows App Store or the Android or Apple's?
Yeah, I think the App Store introduced a little bit of a safeguard. I don't think it's a silver bullet. It will not stop probably all of them, right? As we saw, the Chrome extension, they were on some Chrome store, right? But he introduced a little bit of more safeguard, so you can neutralize pretty much a big part of this attack, and it's good actually having this kind of walled garden model. We created, for this example, we created the Windows 10 S mode. If you want to get the most kind of secure Microsoft device experience, S mode is a super lockdown device where everything must be signed, and there's only like programs and products coming from Microsoft Store. So if you want this kind of experience, the real trick is when you just start having interoperability and you need to now put this device to work with other things, then somehow this device needs to be a little bit open, right? And that's where it gets trickier. Even in the Apple world, I see that a lot of incidents happening, for example, in the iPhone, they were happening with the side-loaded apps, where basically attackers are stealing enterprise certificate to side-load iOS apps which are not in the store. So yeah, the store helps. I think it's a very good measure. That's why also we have Windows 10 S mode. But you need to also still look for this type of external interoperability like side loading, which is another common attack pattern.
Hello, yes. So my name is Daniel here. I come with more of a PKI background. I'm not a developer by any means. But so from what I've seen over the course of time, there's only so much you can do with respect to certificate authority, key management, make sure that you have sound key management and protection principles, access control, and so forth. But then if it's not losing control of a key to be able to, issue a rogue code signing certificate. You can also, as you mentioned here, steal another validly trusted certificate that is in all Microsoft Windows Trust stores, which I know opens another can of worms about how many CA certificates we're all trusting now. But from a developer perspective, I don't know what insight you might have about actually associating code that's actually signed that it must be signed by a certificate from this vendor or manufacturer development team, so that you can't just substitute another validly trusted certificate only just because it happens to be in the same trust store. I don't know if there's been any discussion in that area. In other words, relying party controls. So when you do the validation, are there any additional steps that, given your exposure to these problems, you might see might be worthy discussions to have as far as how we can control it on that end?
Yeah, that's a big question. Like, so the entire space problem in a question, I think. So I see two major areas. Like, first thing is, as I show in the cloud, for example, like there are things that they don't have any trust model. There are no certificates or signing. It's pretty much you rely that you download the package and you hope that somebody verify the hash, but there is no certificate. So that's an area where I think we should put some trust in place. So that's the first thing. Then I agree with you that even when you have trust in place and you have crypto and certificates, you can still have bad practice if the certificate gets stolen or there are other problems. But this is a different set of problems. Basically, you must kind of play a little bit more on the certificate authority side and try to make sure that they can enforce the right set of security control and raise the bar for people that own a certificate. Owning a certificate is a responsibility, and these people actually should be having like much more serious control. So I would probably differentiate the problem in these two categories, but you're right. I mean, the one about even if I have certificates and if I get compromised, that's kind of a little bit of a much bigger scenario, and there is still work to do on that one.
Hello. Going further on that, something that I've had success with, I've seen success with in the past, is tracking the certificate of a certain file path and then notifying the admin if that certificate name has changed for the company. Is there any protections like that in ATP currently where it would alert on that change of the certificate?
So with Windows Defender Application Control, you can define your baseline. So firstly, you can come up with all the entities you trust. I trust only this.
But say we're not ready to do whitelisting. Say like we want an alert in ATP when a file signer changes.
Yeah, well, we don't have anything specific like that, but we see the certificates. Usually we try to raise anomalies like that, but basically they could not be specific to your organization, because in some cases, for example, like things you may care about it, maybe in ATP team we don't know, but yeah, that could be an interesting idea for some of upcoming detection. In ATP itself, you will have eventually the advanced hunting feature, and you may be able to eventually hunt by yourself. You can actually create traps or alerts with your rules, which even the ATP team doesn't even need to know. So that's something that you have as a feature with your SOC and your security team.
Thank you.
Going once, going twice. All right, thank you again, Elia.
Thank you.